Good night, everybody. We're live. I want to remind you of the rules. I want you to pay attention to your background in terms of your noise. Wear headphones or earphones if possible. Please make sure that your video is off for privacy purposes.
Yes, sir.
So we want to welcome a new person tonight. Tony.
Yes,
Tony.
Sir. Yes, sir.
First time in. So you
Yes,
get the
sir.
privilege of answering the first question. Here we have, read for me.
2,915 plus 86 plus 106 plus 8.
Okay, so 8 and 6 would make what?
14.
Okay, so 14 and 6 would make?
20.
And 20 and 5 would be?
25.
Okay, so we're going to write 5 and carry?
2.
So 8 and the 2 would make?
10.
10 and the 1 would be?
11.
Go to write 1 and carry 1. 9 and 1?
10.
And 1?
11.
So we're going to write 1 and carry?
1.
2 and 1?
3.
And our answer is?
3,115.
Anybody got something different from that?
No, sir.
All right, good. So let's, I'm not certain.
Summon.
We're not supposed to be using full names in the group. Let's go now with
Yes, sir. Sir, what is that?
I want you to.
Is noisy.
Yeah. Not certain who it is. The person with that background, you need to go into a quiet environment, please. If not, we're going to have to ask you to leave and come back when the background is quiet. Let's move on. So I'm going to go now to Charlie.
Yes,
this number here, 345. What's this number?
sir, which number? Sir, the one that is under.
No, all of it. What do we call it? 345.
45.
Okay, and the number that is underlined here,
Sir, it is
what number is that? That's what?
Sir, it is 5.
Okay, let's think of face value, place value, and true value. Hold on, let's go back. Yeah, so face value, place value, and true value. So 5 would be the what?
Sir, it tells me
Face value, yes. Face value is 5. Place value is?
Sir, 1.
And the true value would be?
5.
Okay. All right, so anything we need to know about 5, once we do it like this, we'll be able to identify what it is, be it the face value, the place value, or the true value.
Sir, do you want me to tell you what place it is in?
Yes, but we did all of them just in case. What place is it in?
Sir, 3 is in the 100th place.
Okay, 3 is in the 100th place.
4 is in the 10th place.
And this would be in the 10th place.
Sir,
And the 5 would be in the
place or the units.
All right. Okay, let's move on. Hold. Let's go back. All right. So, Welter, let's do some division here. We have
Sir.
what?
0.975 divided by 5.
What's the first step?
Put your placeholder.
Look, pardon me?
Your decimal point.
Okay. 5 into 0?
0.
Okay. 5
Time.
into 9?
1 time.
Okay. Remember, we're going to estimate. We're going to divide. We're going to multiply. We're going to subtract. And we're going to do what?
Bring down.
Bring down. So every dog must swim back. Estimate, divide,
multiply, subtract,
multiply. What's the B for?
bring down.
Okay, cool. So 1 times 5 will give us what? 5. Subtract, what do we get?
4.
We're gonna bring down, or what? 7. And 5 into 47 would go?
9 times.
Because 9 times 5 would give us what?
45.
45. 45 from 47 would leave us with what?
2.
2. And we're going to do what?
Bring down 5.
And 5 into 25 would go?
Go 5 times.
5 times 25. 5 times 5 would give us?
25.
25. When we subtract, we get what?
0.
Okay, if I wanted to prove if my answer was correct, what would I need to do?
Times the quotient by the divisor.
Okay, so this quotient is 0.195. We're going to multiply that by 5. And what are we doing here? We're checking the answer. So 5 5s will give us 25. Right, 5 carry 2. 5 9s would be what? Just mute. Could you just mute that, please? Nice. So let's go. 5 9s.
45.
45 and 2 will give us what?
47.
47. We are going to write the what? 7 and carry 4.
And then
And 5 1s, 5 and 4 will give us 9. And 5 times 0, 0. How many places of decimal we have? 1, 2, and what?
3.
3 decimal places here. So our answer must have 3 decimal places. 1, 2, 3. So my answer would be what? 0.975. Okay, so we get it back so that we know now that it is correct.
Yes, sir.
Okay?
Yes, sir.
So let's remember that what? Every dog must swim back. We need to what? Estimate. We need to divide, multiply, subtract, and
Bring
bring
down.
down. Let's go to Sandre.
Yes, sir.
Ready? This is a place value type question. It says this number, which digit has the greatest value? First, I want you to call this number for me. What's the number?
3,912.
Okay, so the 3, let's put this in expanded form. What does the 3 represent?
1,000.
No. The true value of the 3 is what? 3,000 plus the 9 would be what? 900 plus what?
1.
No, sir, no one at all. What would this be?
10, sir.
10 plus what?
1.
1. This is not 1
2. 2, sir. 2.
plus 2. Okay. So this is the same as saying what? 3 times 1,000. That's how we got that. 9 times place value 100. That's how we got the 900. 1 times 10.
10.
That's how we got the 10. And 2 times 1.
1.
That's how we got the 2.
2.
Are we all seeing that?
Yes, sir.
Yes, sir.
Okay, hold on now. So let's look now, Sandra. It says which of these digits has the greatest value? Are they talking about face value, place value, or true value? Which one do you think they're
Sir.
talking about?
Place value.
No, sir. They're not talking about the place value. Greatest value, sir. They're talking about the true value. So of the digits here, which one has the greatest value? The greatest true value?
3.
Okay, so the 3 has the greatest value. Because the 3 actually
sir.
means what? 3,000.
3,000.
All right. Let's go back to Tony. Tony,
Yes,
we
sir.
have here. Read for me. What's this?
0.04 multiplied by 0.22.
Okay, so we're multiplying decimals here. What did we say that we need to do again?
Sir.
Remember?
No, sir.
Somebody throw our lifeline. What do we need to do?
Sir,
Anybody else?
digits and the digits, sir.
Pass there, so.
Sir, point.
Pass there, so.
Point.
Multiplying decimals. What do we need to remember?
Sir, your point.
More than that.
Sir, you're
Sir,
going to
our
move
place value, sir.
the point,
All right.
sir.
0.04 and 0.22. Any special thing I need to remember when multiplying?
Sir, decimal point on the decimal point.
Yes, but that's not what I'm looking for.
Anything you multiply by 0, you get 0.
No, that's not what I'm looking for. I want you to remember that number of decimal points here. How many decimal points we have here?
Sir, in each.
I have 2 decimal points there, and I have 2 decimal points here.
2 decimal
When I add the number of decimal points, I'm gonna get how many decimal points? 4 decimal.
4 decimal points.
So I need how many decimal points in the answer?
4.
4.
4 decimal points need to be in the answer. Okay. All right. This one not moving.
Sir, how is it that Abigail is on WhatsApp and she is not in the class meeting?
I'm not certain.
Sir,
Someone will have to tell her to watch.
Okay. Sir, I'll tell her.
Hang on a second, please.
Okay.
So our answer needs to have 4 decimal points. So we need to remember that. So Tony, let's remember that when multiplying decimals like this, we need to do what? Multiply like what? Normal. So let's go. 2 4s would be what? 8. And 2 times 0?
0.
2 times 0.
0.
What do we need now?
Placeholder.
Placeholder. 2 times 4?
8.
And 2 times 0, 0. 2 times 0, 0. Do I need to add this 0? Do I need to use this 0?
No, sir.
Because all I'm going to get is another what? String of zeros. Because here, I would need to put a what? Placeholder and then start here. So any number times 0, 0, 0. So all I would have gotten is what? 1 line of zeros. Understood?
Yes,
okay. So let's add now.
8.
8 and what?
8.
And what?
0.
And
0.
And
0.
how many decimal places I need to have again?
4, sir.
Let's count in from right to left. 1, 2,
2.
2,
3, 4.
4,
So my answer needs to be what? 0.00.
0.008.
8.
Are we clear on that?
Yes, sir.
Let's go back over. Whenever we're multiplying decimals, we need to, one, count off the number of decimal places, know the number of decimal places that we need to have in our answer, and then multiply like what? Normal. Is that clear?
Yes, sir.
All right, good. Let's move on. Tally, you're up. Read for me.
So $90,005.
Which one of these would represent that? Here are the options A, B, C, and D. Which one represents $90,005?
Sir, B.
B. Sure. Let's check out the place value. Tally, help me. So the first place. Somebody's background is noisy there. The first place to the left of the decimal. What is that one called?
Sir, which one are you talking about?
Look, here's the decimal point. Decimal point and the decimal point. The first place to the left of the decimal point. What place value is that?
Sir, that is a tenth place.
No, it's not. To the left, not right. To the left. So where this 5 is? The 5 is in the what place?
1 space, sir.
Ones. Okay. So this is ones. The place to the left of the ones place would be what?
10.
Okay, tens. The place to the left of the tens place would be what?
100.
All right, so this is hundreds. The place to the left of this would be what? To the left of the hundreds would be what?
Thousands.
Where's that ringing coming from? Hold on.
So that sounds like your timer.
Yes, hold. All right. So we turn off the timer. Let's get back. So this would be 1,000. The place to the left of 1,000 would be what?
10,000.
10,000. The place to the left of 10,000 would be what?
100,000.
100,000.
All right, 100,000. All right. The place to the right, the first place to the right of the decimal point represents what?
Tenth.
1 tenth. Okay, tenth column. And the second place to the right of the decimal point would be what?
100.
Would be? Nobody's saying anything. Come on, look.
100.
What would be hundreds? Why don't I have thousands here? Tell me. Could someone put that phone on vibrate, please? So that it does not disturb our meeting.
Sir, there's nothing there.
No, that's not why.
Sir, what is the reason?
Because we're dealing with dollars and cents. How many cents make up this section of it? 100 cents make $1. So I don't need to go to thousands. Okay.
Yes, sir.
All right. So we don't need this one. So let's go now. Tally, this is $90,005. So what we need in the ones column, we need 5, right?
Yes, sir.
Okay. all of them have 5 in the ones column. Can we use that to distinguish any of our options?
No, sir.
Okay. In the number, this number, $90,005, do we have any tens there?
No,
No.
sir.
Okay, so we can't use the tens column to distinguish between our options. Let's go to the hundreds column. This one has 9 here. So this look like it wrong then, not true?
Yes, sir.
Yes, sir.
Because this doesn't go any further. Okay, let's go over to the thousands column now. How many thousands are there? 90 of them. Okay, is this 90 thousands
Yes.
or only 9? Okay, so this one not right either. What about this one here? So how many thousands?
900.
Yes, this will be 900. So this is out as well. And the
So
one
that's
that we want is what? The one that has what? How many thousands? 90.
90.
Okay, 90,000.
Sir.
So only that one is correct. Got it? The person with the phone, please. You have to. You can't do that to us. Do you see how we have to make sure that we understand place value properly in order to be able to answer the question?
Yes, sir.
Okay. Pay attention to where the digits will fall in the place value chart so that you're able to quickly identify. And look at what they have done. They have given you what? This number in what? Words. And you need to convert it to what? To numbers.
Sir, this is question how much, sir?
3.
I'm not certain.
So that is number 3.
All right, let's go. Let me see who is next.
Walter, sir.
Let's go. TC, you're up. 32 tenths. What is that as a decimal? Let's convert the 32 tenths to decimal. What do I need to do?
That would be 0.32, sir.
No, sir, that not sound right at all. Just does it sound of it, sounds right at all.
Sir.
Because he said 0.210.
No, it's not that. 0.32.
Still not feel that right at all. Look again.
Sir, 3.2, sir.
That sounds more like it. How?
Because
No,
Sir, it is 3.2.
that person answering is come. Ready now.
Sir, you divide 32 by 10.
Good, you divide 32 by 10 because the numerator is actually the what? Dividend, and the denominator is actually the what? Divisor. Okay. So let us set this out. We can set this out, no? So we could say what? 10 and we have 32. And say 10 into what? 32 goes 3 times. 3 times 10 will give us 30. Subtract, we get 2. 10 can go into 2. Decimal point and add 0. And 10 into 20 what? 2, because 2 times 10 would be 20. Subtract, we get what? 0. So you see how we get the 3.2, right?
yes,
Yes,
See
sir.
there, sir? Those two are the same.
Yes.
But
Yes, sir.
remember, we could also do it like this. 32 over 10. The decimal point, the unstated or unseen decimal point is where? To the right of the whole number. Okay.
Number.
Now,
Yes, sir.
if I'm going to divide by what? 10, I am going to what? Move that decimal point how many places? Based on the number of zeros? 1 time.
1 time.
So now this becomes what?
3.2.
3.2. Understood? Now, please remember when you go to high school, you're not moving any decimal point. You'll be actually moving the digits. But just for
Yes,
now,
sir.
bear that in mind that we are moving the decimal point.
So
Okay?
when I went to Miss Reed's summer school, she said that we should never move the decimal point.
All right. This is just a shortcut, fast way of doing it.
Yes, sir.
Okay?
Yes, sir. Sir, people keep on leaving, and
Okay. Let's see. Somebody keeps coming in and dropping out. I'm not certain who it is. All right. So let's go.
It's Trevon.
All right. Let's go back until they get here. Let's all do this. We have 0.4 what?
8.
0.488. And we're going to divide that by what? 0 point.
0.8.
All right. What do I need to remember when I'm dividing by a decimal?
Sir, what is it? Oh.
Sir, I am back, sir.
Very good. Somebody has their video on for privacy purposes. We can't have any videos there.
Well, thirsty.
Okay. Let's go now. So what do we need to remember when dividing by a decimal? We did this in lessons the other day. Come on.
Sir, I am confused.
Sir, repeat the question, sir.
What do we need to do when dividing by a decimal? When the divisor is a decimal, what do we need to do? Still waiting.
Sir, dividing by a decimal, we move to the left, sir.
That's not what I want to hear.
Sir?
Anybody remember saying that we need to change the divisor to a whole number by multiplying it by a power of 10?
Yes, sir.
You remember that?
Yes, sir.
Okay, so what power of 10 will I need to multiply by to change this divisor 0.8, which has only one place here of decimal?
10.
Okay, so if I multiply this by 10, this will become what? 8. And if I multiply the divisor by 10, I'm also going to need to multiply the what? Dividend by 10. And this will become what? 4.88. Okay.
Yes,
let's set this out another way. 0.488 all over 0.8. I move it one place. I move this one place. You notice the same thing, that the same movement I make with the what? Divisor, I make with the dividend. So I end up with 4.88 divided by 8. Let's set this out as 4. No, not 4.
Sir, can you tell these children that if they're joining the meeting, they should stay and stop exiting it every minute, please?
I am not certain who is jumping in and out.
Sir, sometimes he's having a problem, sir.
All right, could you just send him a message to watch instead of joining, because it's kind of distracting. Sir. All right, let's tell him to watch. Forward the link to him so that he can watch. All right, so let's go. Remember, step 1, we're going to bring the decimal point right back where it was. 8 cannot go into 4, but 8 could go into 48. How many times? Come on with the multiplication facts quickly. 8 into 48.
6 times.
Okay, because 6 8s give us 48. We have 48. We subtract, we get 0. We bring down, we get 8. And 8 into 8 goes what?
1 time.
And 1 times 8 is 8. Subtract, we get 0. We're going to test now by multiplying the what? Quotient by the divisor. Okay, so let's see if this works. So we have 0.61. And we're going to multiply that by 8. So 8 ones will give us 8. 6 8s, 48. We're going to write 8 and carry 4. And 8 times 0 is 0, and we bring down back 4. We have 2 decimal places here. Remember that this is 0.61. So we need to have 2 decimal places. 1, 2 places here. So 4.88.
8.
And that's what we got there.
Yes,
So
sir.
we know that we are correct.
Yes, sir.
Let's look at this fraction problem. What type of problem is this? What type of
Sir,
fraction problem is this? An addition problem,
problem.
yes. And are these mixed improper like on what are they?
Mixed numbers.
Same denominator or unlike?
Unlike.
What does that mean? In order to add them, we need to make them what? We need to make them.
Make them the same, sir.
We need to find the lowest common denominator or lowest common multiple, which is the same as finding what? An equivalent denominator for both.
Yes, sir.
Sanjay, help me to change these from a what? Mixed number to an improper fraction. What do I need to do?
4, 2, 4, 4, 4.
Not hearing him. Are you there, sir? All right, Tony, what do I need to do?
Sir.
Tell me what I need to do to change this. Yes, go ahead.
Sir, turn the mixed fractions, sir, into improper fractions.
Yes, tell me how to do it.
Sir, you multiply the denominator by the whole number and add the answer by the numerator.
And add the numerator. Hold on, let me see if I can find my place. Okay. I'm not certain who is trying to call me here. Guys, give me a minute. Let me find out who is this.
Okay.
Hello? Hello? Meeting done?
No, Sanjay.
Trevon.
Okay. Sorry about that. Could somebody... All right, guys. Ready again. Could somebody send the link out to Akeem? Tally, could you send the link for Akeem to watch, please?
Okay, sir.
All right. So let's go back now. Those phones on vibrate. Oh boy. Ready? Tony?
Yes, sir.
So you were saying 4 times 1 would give me what? 4. And what do I do?
Multiply, add the 4 by the 3.
I don't like how that sounds. Say it again. Say it a different way.
Sir.
4 times 1.
4.
4 ones 4.
And 4 times 4 plus 3.
Okay. 7 over 4. Plus, let's go.
4, 8, 32.
And the 1 and 1.
33.
Over what?
8.
LCM.
Sir, 8.
Okay. And 4 into?
8 2 times.
2. Use that factor of 2 and multiply the what?
Multiply the answer that you get by 7.
Yes. So 2 7s would give us what?
14.
Okay. And 8 into 8?
1 time.
1 times the 33 would give us?
33.
What do I get as my answer? 14 plus 33 would give me what?
47, sir.
47 over 8. How many times can 8 go into 47?
How many times 8 can go into 47, sir?
Yes.
6 times, sir.
6,
Remainder 1.
6 8s, 48.
8, sir.
Okay, that's a little bit more, huh?
Yes, sir.
Or a little less.
A little bit more.
I
Sir.
have what? 47 and 6 8 would give us 48.
Yes, sir.
So will it work like that?
No, sir.
So what will I need to do then?
Sir,
Sir.
8, 8,
Sir.
7.
Go ahead,
Sir,
work.
8, 7, sir.
Which is what?
Sir, 63. No.
Mm-mm.
Um, sir,
Sir. 18.
sir,
18 to
Sir,
87 goes 5 times, sir.
50.
No. Who's doing that? Can't do that. Can't do that.
Sir. 18 to 47 goes 5 times, sir.
How many times?
5 times.
Okay, remainder what?
7.
Okay.
7.
So 5 times remainder 7 over 8.
8.
Okay. Let's try this. That's one way of doing it. Let's try it another way. We can look at the whole numbers. So
Yes.
1 plus what? 4 would give us what? 5.
5.
So 1 plus the 4 whole number would give us 5. And we're going to add that to whatever we get for the fractions now. So 3/4 plus what? 1/8. LCM 8. 4 into 8, 2 times. 2 3s, 6. Plus 8 into 8, what?
1.
And 1 times the 1 here would give us what? 1.
1.
What do we end up with? 7 over 8. And we're going to add the 5 to that. So this would be 5 plus 7/8, giving us what? 5 and 7/8. All right, remember now, which way is easier?
Sir, the one that you work it out with the change
I
it to instructions.
Okay. That one is easier for some people, but I'm showing you two ways. So either way, if you want to deal with the whole numbers by themselves, but you have to remember when you get here that you'll have to add this one to this.
So which way should
Okay?
we do it in exam?
No. Whichever way you think is easier for you. All right? But I'm showing you both ways. You pick one. Pick the one that you understand best. So some people will stop here and think that this is the answer, 7/8.
Sir.
But it's not complete because you need to add the 5 whole to the 7/8 to get 5 and 7/8.
78
Clear?
plus 7 over 8.
All right. Then this one, when you convert, you end up working with larger numbers. The largest number I have to work with here is what? 47. The largest number I have to work with here is 8. So some people prefer to work with the smaller numbers because it's easier for them to calculate. Okay, so you have two methods to use. Pick one, the one that you understand best.
Excuse me, what is you tend to want to watch the video instead of joining and leaving the meeting?
Pardon, I'm not hearing you.
I'm talking to Walter. I'm asking if he told Trevon to watch the video instead of joining it and leaving it so many times.
Sir, and I leave it. It does not work good for me. Every time I come in, he come back out.
All right, watch it this time around, okay?
Yes, sir.
Send him the link. Send him the link so he can watch.
Yes, sir. Come in.
All right, good. All right, let's go. Next one. Which shows TC, this one is yours.
Sir, I'm sending Trevon a link to it.
All right, so let me go back to Tony. Tony, which shows improper fractions only? Here I have some fractions. Improper fractions only. The question is, what is an improper fraction then?
An improper fraction is when the larger number is big, the numerator is larger than the denominator.
And you know that is not 100% complete.
Sir, or when the numerator and the denominators are the same, sir.
Okay, so it is either larger than or equal to the denominator, the numerator rather, is larger than or equal to the
Sir, because
denominator.
sometimes they have it and both the numerator and the denominator are the
All right,
same.
good. So let's look now and see, Tony, is this
Yes, sir.
set? Let's call this A, B, C, and D. Which one of these shows only improper fractions? And pay attention to this word, only. This is an important word in answering this question, only. So we know what improper fractions are. We know what the improper fractions are, and we know what only means. So let's go with that and see.
Sir, all of them, sir, they have improper
Fractions
fraction.
in them, sir.
Improper fraction.
Which one has only improper? All
Sir,
right,
because for B, it's not only improper fractions because you have
2/5.
okay,
sir,
so
and 7/10.
2/5 is proper. That means that B cannot be right.
Sir, A
And-
cannot be right, sir.
And 7/10 is here. So that one wrong. So this cannot be
Sir,
right
and
at all.
3/4.
Hold on. Let's go back to A. 3/4. That is proper. So that one can be right. All right. So once one of these incorrect, then all of it is incorrect. Tony,
Yes, sir.
tell me what is wrong with C.
Sure.
Improper fractions.
Have you seen it yet?
Yes, sir.
Tell me what's wrong with it.
Sir,
Is this 2 larger than or equal to the 3?
yes, sir.
No, sir.
No, sir.
No, sir.
So this one is not improper. This is actually a proper fraction.
Sir,
So
and
this
Oh, sir, the answer
and,
because
and
the
3/4
second
is
one here looks
also
like 5.
okay. So this one is out. Let's look at the last one, Tony.
Yes, sir.
5/3. Okay, that's good. 3/2. That's good. 7/5. That's good. And 9/8. That's good. So this one is
yes,
correct.
Sir, you know why, sir? Because the second one, it
Yes, sir.
looks like a 5, sir.
Which
sir,
one?
it looked like it was
Sir,
writing a
the
7,
second
but
one in B, sir. In B.
No, no. In B,
B for dog.
D for dog.
Yes, sir.
The
It looks
second
like
one.
Which one?
Sir, the second one.
This one?
Yes,
Yes, sir.
sir.
Yeah, but whether it is, oh, you're saying this 2 years or?
Yes, sir.
It looks
Okay,
like a
cool.
5.
yes, sir, it's true.
All right. So we need for this question, we need to know what an improper fraction looks like and what the operative word here only means. It means that I can't have a mixture of anything else.
Yes, sir.
Got that?
Yes, sir.
Let's go back to Sandra.
Yes, sir.
All right, so ready now. What are the prime factors of 42? What will I need to do? Anybody wants to help him? What would I need to do to find prime factors?
Draw your factor.
The ladder method or the
Ladder.
Oh, okay. So we have ladder method versus what?
sir.
All right, let me start with factor 3. Factor. 3 first. Hang on a second. Yeah, go ahead.
Sir, 2, sir.
Okay. 2.
Sir,
What
2
can I
and
multiply? No, 2 times what would give me 42?
2 times 15.
No, sir. 2 times 15 at 30.
Oh,
42. Break 42 into 2 parts.
21.
Sir, 21 and 21.
21. All right. So 2 times the 21. This one is already prime, so we don't need to do anything with it. Write it back. Let's break 21 into prime factors now.
7 times 3.
Or 3 times 7.
Yes, sir. Sir, all of them are prime now, sir.
So we can continue there.
Yes, sir.
So this method is the what? Factor
Factor 3.
3. All right. So let's get them. 2 is prime, 3 is prime, 7 is prime. Let's go now with our ladder method. 42. Starting off with the smallest prime. 2 into 42 again would go how many times? Come on, guys.
21
Multiplication for
times.
21.
21 times, sir.
Can I use 2 into the 21?
No,
No,
sir.
sir.
What will I need to use now?
3, sir.
Why do I need to? Why can I use 3?
Because the sum of the digits is a multiple of 3, sir.
Very good to hear the divisibility rules. Why could I use 2 here?
Sir, because
Excuse
the digit in the ones place is 2, 0, 2, 4, 6, or 8.
All right, good. You know that this number is also divisible by what?
3, sir.
3. But we start with the smallest prime first. And
Yes,
if
sir.
2 can go in there and 3 can go in there, what other number could have gone into this?
Sir, 6, sir.
All right, very good. So let's go 3 into the 21.
7 times.
Okay. So 3 times 7 will give us 21. What can go into 7?
7 itself, sir, because it's a prime number.
Yes,
Excellent. So the prime factors here again,
sir.
2, 3,
3,
and
7.
7.
Said that she soon joined, but the meeting she has to eat.
Oh, okay. All right.
So from school, so nothing now. She just eat
All right,
them.
ready. Let's go. We have 614.285, and we need to know what's in the
100th place.
100th place. So 6. No, let's start with the decimal point, and let's look at the number to the left and to the right.
Right.
To the left of the decimal point, we have what place?
Ones place.
Ones. To the left of the ones place, we have what?
Sir, tens place.
Good. To the left of the tens place, we have what?
Hundreds place.
Hundreds. All right. To the right of the decimal point, we have what?
Tenths place.
To the right of the tens place, we have what?
Hundredths
Hundred.
place.
To the right of the hundreds place, we have what?
Thousands place.
Okay, so we're going up by powers of 10.
10, yes, sir.
All right. So it asks us for what place?
100th.
All right.
Which
I'm
is
going to do something, and you tell me if I'm right.
No, sir.
Why not? You know, say 100.
No,
See big old 100 here. So what's
No,
wrong with
sir.
that?
The
100.
TH is on it.
It's not
Oh, so what? It not hundreds, hundreds.
100.
Oh. So what
Yes,
this mean
sir.
again?
Sir, 1/100.
Okay, it means out of what? 100 pieces.
Yes,
So
sir.
which one is there? Is it 2?
No,
No,
sir.
Is
so
it
that's
5?
No, sir. It's the
Which one is
8,
the
sir.
correct one?
eight.
Yes.
8.
Okay. Place value is very important. Okay.
Yes, sir. Very
Let's
good.
go on quickly.
Mm.
Everybody's favorite.
Sir, oh, you know that is our favorite. I suppose
Favorite
it's
man.
sir.
After the test today, everybody's favorite. Let's go.
Medical Xavier.
Call.
Exit.
Xavier.
All right. What does the M stand for again?
Sir, what?
1,000. D.
500.
500. C.
100.
Sir,
L.
50.
see,
X.
10.
10,
V.
5.
5,
I.
1.
1.
Okay, so here I have M, which is 1,000, but to the right of the 1,000, I have 100. When I have a what? Symbol of lesser value to the left of a number of greater value, what do I need to do?
Sir, subtract, sir.
Good. So 1,000, now we're going to take what from it?
Sir, 100.
So CM represents what?
900, sir.
All right. XL. L
Sir.
represents what?
Sir,
50, sir.
And we have
40,
X. So XL represents what?
40, sir. And
Okay.
IB represents
And we have
4.
meaning what?
4.
So this is and what?
44.
So CMXLIV actually means in our.
944, sir.
4.
Are we clear?
Yes, sir.
Everybody's favorite.
Not really, sir.
All right. Sanjay, call this number for me.
Oh, so you know what some of the children say when they give them some work to do, sir, and they know that they can't do it, they don't answer.
Not hearing him. If you can't answer, sir, just tell us that you can't answer. We're not going to know everything all the while. Are you there, sir? All right, moving on. Tally, can you call this number?
Sir, let me sir, that is 16,400. Sir,
20.
4,021 and sir, that is 16,421
Let me add these and maybe it will help you.
no, sir.
Sir, 16,421,042, sir.
Okay, 16,421,000 and what? 42.
2.
Let's go with the place value
Face value.
and fix these in. So this would be what? Or ones, this, or tens, or what? Hundreds, 1 in our thousands, 2 in our 10,000s, 4 in the what? 100,000s. Then we have what? 6 in the what? Millions. And 1 in the what? 10 millions place. So this is always a one set of 10 million plus 6 million gives us what? 16 million. Then we have 400,000s plus 20,000 plus 1,000 gives us 421,000.
1,000.
No, yeah, man. No hundreds,
No, sir.
but 410 and
And 2
two one.
ones.
This
Are
gives
you
us
on it?
42.
No,
All right.
I remember.
So this now, yeah, man. This gives us 16,421,042.
Sir, so is anytime you're doing numbers, you should remember your place value.
Must.
Yes, sir. Must.
Yes, sir.
Can't forget it. It's like the air we breathe.
Yes, sir.
Arrange the following numbers from largest to smallest.
So here, what's the same?
Let's
Sir,
go.
0
Arrange
point
largest to small.
0
Here.
point 125 0.250
Yours.
0.000.
All right, one at a time, because we're talking over each other and we can't hear clearly.
Sir, I will say it, sir.
TC, what do you think is the largest one?
0.125.
Incorrect, sir.
0.250 then. No,
Incorrect. Largest.
0.002, sir.
Not correct. In fact, that is the smallest one.
Oh, the
It's
smallest. 0.600.
All right, stop. Let's look at this.
Sir,
If this is the whole number, so this is our ones place. This is our tens, our hundreds, and our thousands. Since we have three places, we know we have somebody's microphone is way up. Can you hear the loop back? Can you hear the loop back? All right. So we have 0.125, which is actually 125 pieces out of what? 1,000.
1,000.
Then we have 250 pieces out of 1,000. Then we have two pieces. 2 pieces out of 1,000. And the last one, how many pieces out of 1,000 for the last one?
6.
No, sir.
600.
600 pieces out of. So let's arrange these now with the largest one in mind to the smallest one. Which one comes first?
Sir, 2 over 1,000.
2 over 1,000, largest.
No, sir, no, sir.
If I was going to share up a pizza with you,
600 over
and I give
1,000.
you, okay, 600 over 1,000, then which one would come?
250.
250 pieces out of the 1,000. Then
125
125 over 1,000
And then the 2
and 2 over 1,000. So if we
so that is over 100.
oh, I'm sorry, let me fix that. Good. So let's go. So this one would come first. So this is first.
Yes, sir.
Then this one is what? Second.
Second.
Then third. Finally fourth. So we would write it out like this: 0.600, comma, 0.250, comma, 0.125, comma, 0.002. So this is what it would look like in decimal form. Got that?
Yes, sir.
Yes, sir.
So you see that place value is important not only on the whole number side, but also on the what? Decimal side. And this is what? Comparing decimals. Comparing decimals.
Decimal.
What is 36 as a product of its primes in exponential form? What will I need to do to get that?
Sir, do the prime factorization.
All right, so 36. 2 into 36 will go
Sir, 18 times.
18. 2 into 18.
9 times, sir.
Can I continue using 2?
No,
So I
sir.
go to next prime, which is 3. 3 into 9.
Sir.
3 into 3.
1 time, sir.
1 time. So this will be in exponential form. This is what?
2 squared
So
or
we
2
have
to
2
the
times 2 times 3 times 3. So this is really what?
2
2
squared or 2 to the
squared
second power.
Times 3.
Or 3 squared
multiplied by
3 squared
3
or
squared
3 to the second
or
power.
3 to the second power.
Power.
Any questions?
No, sir.
All right, so we're moving along.
Sir, it looks like, sir, are you doing 11? Oh, sir. Sir, it looks like you're doing 11 questions. So far, I've done.
Okay, so here we have another one. Max scored 45 out of 50 on a math test. What is that score as a percentage?
Sir, 95.
95. All right, so let's put down the 95 as a possible answer. Any other possible answers?
No,
Anybody
sir.
else? All right.
95 or 96.
All right, so we have 96 as another possible answer. Any
Sir, one
other?
of for me, sir.
All right. So 45, the total number on the test was 50 and he got 45. Percentage means I'm going to multiply by 100 because percentage must have 100 out of 100. All right,
Yes,
so
sir.
highest common factor of 50 and 100 is what? 10. 10 can
Yes,
go
sir.
into the 50
5
5 times. 10 can go into the 100 10 times.
times.
5 can go into itself 1 time.
1
5 can go into 10 2 times.
2 times.
45 times 2 would be what?
Sir, 90, sir.
Okay, 90.
Oh,
All right. They asked me for the answers of what? So
Percentage.
if I write so 90, I am not correct. It's actually 90 what? Percent. It's actually 90 what?
percent.
Percent.
Okay. Any questions?
No, sir.
No, sir.
What is 5 and 2/3 rounded to the nearest whole number?
Sir, 6,
All
sir.
right.
Yes,
I
sir.
hear 6.
No, sir. I don't think so.
All right. So let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's pretend that this is our number line. Or number what?
Line.
Line.
Between 1 and 2, I'm going to have all the little fractions, 1.5, 1 3/4, etc. The number that they have is 5 and 2/3. So that would mean that we're dividing this section here between 5 and 6 into what? Thirds. 1, 2, 3. Now 5 and 2/3 means that it's about here. So is this number, if a number was here, would it be closer to 5 or closer to 6? That's what it's asking.
6.
So it's closer to what? Closer to
6.
6. Let's do this now
Answer.
as a decimal and see what that would be. So we have 5 and 2/3. Let's look at 2/3 as the decimal. So 3 would be the divisor and 2 would be the dividend. So
Yes,
let's
sir.
go now.
Then, sir, I was
3,
calling,
3 into
so
2,
I
3
need
into 2. Can't work. Add 0. Add a decimal point. Add 0.
yes,
3 now
sir.
into 20 goes what?
Sir,
6 times, because 6 times 3, 6
eight,
threes.
80.
Subtract and I get what? 2.
Sir,
Add 0 again to continue. 6 again. 6 threes what? 18.
18.
Subtract, get 2, add 0. And we can continue like this and we get what? 0.66666. Can we continue?
Yes, sir.
All right, because this is recurring. So this as a decimal would actually be 5.66. Understood? Because
Yes,
look,
sir.
5 plus the 2/3 is the same as 5 plus 0.66.
Yes, sir.
Okay? So we end up now with
Yes, sir.
5.66. Let's round this off to the nearest whole number. Let's look to the, if I'm rounding to
Sir,
5, which is the nearest whole number, 6 is in which group? The rounding up group or the rounding down group?
rounding
Rounding
up
up.
because
Okay, so when
five.
I'm rounding up, I'm going to add 1 to the digit that I'm rounding. So 5 and 1 would be 6. And I'm going to put 0 for the rest. So
Yes.
I end up with what? 6.
6.
Somebody's microphone there, the background.
Sir, cool picture.
We don't call our full names here, sir. All right. So moving on, we have a few left to go. John is 2 years older than Bill. The sum of their ages is 36. How old is John? I want you to watch this one. I don't think that we have done any questions like this, but this question will focus on algebra. So John is 2 years older than Bill. So whatever Bill's age is, we're going to have Bill age plus 2. So this age is Bill, and this one represents John. When we add these two ages, we're supposed to get 36.
6.
We're going to add these two. We'll get 2b plus 2 equal to 36. Got that? We're adding our like terms. B and B will give us 2b, and we have 2. I need to get rid of this 2 on the left-hand side of my equation. So I'm going to say this is 2b plus 2, actually minus 2. So we're taking away 2 here on the left-hand side. So we need to take away 2 on the right-hand side to maintain it being balanced or to be equal in what we're doing. So if I do something to the left-hand side, I need to do it to the right-hand side as well. So 2 will cancel 2 here. So I'll be left with 2b being equal to 36 minus 2. That will give us 34. Please follow along. Now I have 2b is equal to 34. So 2b is equal to 34. I will divide this side by 2 so I can get b by itself. And if I divided what? The left-hand side by 2, I need to divide the right-hand side by 2 as well. So 2 into 34 would be equal to b. So b is equal to what? 17, because 17 times 2 will give you 34. If we have 34 and we break it into 2, we have 17 in each group. Now,
Yes, sir.
look at what it says. They want us to say how old John is. Wherever I have B, I'm going to substitute and put what? 17. So B plus 2 is equal to 36. Let's see if this is so. So B represents what? 17 plus 2 should be equal to what? 36. Now, 17 and 17 is 34. 34 and 2, 36 is equal to 36. So I know that the B is correct. Now, is my answer 17? Is my answer 17? Is John's age 17?
Yes,
No, it's
sir.
not. No, it's not. Because John's age is actually B, the age of Bill, plus 2 more. So if Bill is 17 years old and John is 2 years older than Bill, Bill can't be 7, John can't be 17 as well. He must be 2 years older. So it will be what? 17 plus the 2 years older, making John how old? Therefore, John age is what?
19.
17 plus the 2 equal what? 19. Understood?
Yes, sir.
Yes.
So let me run quickly through this again. John is 2 years older than Bill. So whatever Bill is, we're going to add 2 to this in order to equal John's age. See that?
Yes, sir.
The sum of their ages is 36. So when we add Bill age and John age, we must get what? 36.
36.
This is how we ended up with the expression, sorry, the equation. Bill's age plus Bill's age plus 2 is actually equal to 36. John's age is represented by something, what? Being added to 2. All right? So we put our like terms together. When we have our like terms here, we'll say B plus B, and this will give us 2B plus 2, giving us 36. We're going to remove 2 from the left-hand side. Whatever we do to the left-hand side, we must do to the right-hand side as well. So we're going to remove 2 from this side. So 2 will cancel 2 here, leaving with 2B on the left-hand side and leaving with 34 on the right-hand side. So we have 2B being equal to 34. So we'll divide the left-hand side by 2 to get rid of 2. And we'll divide the right-hand side by 2 because we divided the left-hand side by 2. And anything done to one side of the equation must be done to the other side as well.
Yes, sir.
Okay, so now we'll have B being equal to 34 divided by 2, which gives us 17. 17 is not our answer. 17 only tells us how old Bill is. Bill is actually 17 years old, but John is what? Whatever Bill is now plus
Plus
2
2.
more years. So that's how John's age is actually what? 17 plus the 2, 19 years. And if we go down here, we check it and we can see that B plus 2 is equal to 36. 17 and 17, which is the
Plus
B
2.
plus 2, would actually give us what? 34 and 2, 36. 36 is equal to 36. And if I work it down to this, I know that it's what? Balanced. All right. So we got that. All right, ready, guys? Let's look at this. We can run through these quickly. What does 3 represent?
Same.
Intersect B, sir.
It represents the intersection of set A and set B. What does that mean? When you say represent the intersection, what does that mean?
It's
A
both
and B.
of the sets.
That 3 is common to A and B.
B.
How many members are in set A and set B combined?
7, sir. 7, 8. 8.
How many?
7
Come on.
with the intersect one, that is 8.
Okay, so we have 8.
Both of them.
The union A union B would be equal to 8. 8 members or 8 elements.
Yes, sir.
Okay, the union of set A and set B, 8 elements.
Yes, sir.
All right, Corey, are you there?
Yes, sir.
All right, tell me what is the best description for 3, 5, 7, and 9?
Sir, all of them are odd
They are all what?
numbers.
Okay, so odd. Why you said they are odd numbers?
Because only
Okay, the only numbers that can go into 3, 5, 7, and 9.
Can't hear you. Say again.
The only two numbers that can go into 3, 5, 7, and 9. Actually, they're not actually odd numbers because 3 and 3 can go into 9 3 times. So that's
I don't know if it's your background, but you don't sound very clear at all.
Sir,
Somebody else pick up for her until she starts that out, please.
sir, because when you divide them by 2, sir, they leave a remainder of 1, sir.
Excellent. So all these numbers, 3, 5, 7, and 9, are not exactly divisible by 2. They have a remainder of 1. So those numbers are classified as odd numbers. Remember, we need to know for the purposes of the exam, odd number, even number, square number, composite number, all of those. All right? Prime numbers, whole numbers, counting numbers, all of those things, we need to have them ready. Okay, moving on. Which ratio is equivalent to 20 to 36?
Sir, I think the A.
All right, let's look at it. 20 to 36 can be expressed as a fraction, which is what? 20 over 36. Can we reduce?
Yes, sir.
Yes, sir.
What could go into both 20 and 36?
4, sir.
4. So 4 into 20 would go.
5,
5 times.
4 into 36 would go.
9 times.
So we end up with 5 ninths. But 5 ninths doesn't look like this. What can
No.
we do to change this fraction into a ratio? Numerator becomes the first term and the denominator becomes the second term. So this now 5 over 9 becomes 5 to 9. Okay? And if we had A, B, C, and D, our answer would be option what?
A.
Option A. All right, quickly. $810 is shared into the ratio 2 to 7. How much is the smaller share? Anybody remembers this one?
No, sir.
All right, let me go ahead with this. So first thing that we're going to need to do, we're going to need to add the ratio to determine the total number of shares. So this will be what? 2 plus what? 7, giving me 9. So the total number of shares is 9. Okay. So this really means, and this is the smaller share, and this is the larger share. They want me to find the smaller share, which is the 2. So it would be what? 2 parts out of the total what? 9. Multiply this by 810 over 1. 9 into itself one time. 9 into 81, 9. Bring back the 0. So 9 into 810 actually goes 90 times. Multiply now numerator by numerator. So this will be 2 times 90, giving me 180 over 1, which gives me 180 because any number divided by 1 remains the same. So this was in dollars. So my answer needs to be in dollars as well. So $810 when shared in the ratio of 2 to 7, the smaller share is $180. See that? Got that?
Yes, sir.
Okay. So what should the other share be equal to? If we know that the smaller share is $180 out of the 810, what should the larger share be equal to? We could simply say what? 810.
10.
And what do we do? What?
Take away, sir.
Take away what?
Sir, wouldn't you just put the 2 dots between them?
Take away the 180 from it and find out what is left. Subtract 0 from 0. 0. 8 from 1. Can that work? No. Take 1 from the 8, leave me with 7. That 1 no makes this one here. Adding the set of 10 and that, it will give me 11. 8 from 11 will leave me with what?
3.
3. And 1 from?
6.
Okay, 6. So the larger share should be 630. Hold on. Let's see if this is actually so. By using, or what? Using the 7/9, multiplying this by 800 and what? 10. 9 into itself one time, 9 into 810, 90. 7 times 90 would give me what? 630. If I add the 630 and the 180, then I should get back the total. So let's look at that. 180 plus 630, add the 0 and 0, 0, 8 and 3, 11, carry 1, 6 and 1, 7 and 1, 8, 810, which is what they had here. I need you to pay attention to this one. We haven't started it yet, but someone sent in the question and we're looking at it, so you get a better understanding for it. So if we have an amount of money and we need to share it in a ratio, we're going to look to convert this ratio, adding it, so we know the total number of shares and treat each term as a fraction of that particular whole. The whole in this case would be what? 2/9 plus 7/9, giving me a whole of what? 9/9, which is the same as 1. Understood?
Yes, sir.
Okay. Let me see. All right. 2 more questions to go and we're done. A man has 2 times as many mangoes as his neighbor. Together they have 12 mangoes. How many mangoes does the neighbor have? So I'm going to put these out so I can see them. Man and who? Man and his neighbor. Okay. So the man has 2 times as many as his neighbor. I'm going to call the neighbor N. I'm going to call the man N, because the man has 2 times as many as his neighbor. So he'll have 2 times N, and together they have what? 12. So it is 2N plus N would be equal to 12. Now if I have 2N plus N, this will give what? A total of 3N being equal to 12. I need to get rid of 3, divide this side because it's being multiplied, divide it by 3, and I divide this side by 3 as well to make it equal. So N should be equal to what? 3 into 12, 4 times. All right. So if N is equal to 4, let's look at this and see if this is right. So the neighbor would have how many mangoes? Just put the N back in there. How many mangoes should he have? How many mangoes?
12.
Anybody? Man can't have 12. The total number of mangoes they have would be 12.
Sir, so it would be 6.
There would
No,
be
it
4,
can't be
sir.
6. It would be 4 because you're simply going to substitute and put the 4 in wherever you have N. So while it is that the man has 4, the neighbor has 4, the man would have 2 times the 4, giving us what? 8. So that's how we end up with now 8 for the man and 4 for the neighbor. 8 and 4 giving us what? 12 mangoes in all. Last one. And we're done there. All right. Thank you guys for joining. When you have the opportunity, play the video over and go through especially the last 2 or 3 that we have done so that you get a better understanding of them. So when you actually start seeing those questions more than you're seeing them now, you'll be better able to answer them. Thanks for joining, and I'll see you in the next episode.
Yes, sir.